Hi everyone, welcome back to class. I have some exciting news. I have colored markers today. We're going to start with a brain check. For this brain check, I just want to review all of the reactions we've talked about with alcohols, except for the Grignard reaction, which we're going to spend a lot more time talking about today. So here are a bunch of different functional groups on the board, and what I want you to do is to pause the screen for a minute, copy this down, and see if you can fill in the reagents that you need to do these transformations. What would you use to turn an alcohol into an aldehyde? What would you use to come back to the alcohol? Same thing for the carboxylic acid and for the chlorides and the bromides. And here we have a primary alcohol versus a secondary alcohol. So take a minute, pause your screen, see if you can come up with the answers. And when you're done, I will go over this. So let's start over on the left side. A secondary alcohol. When you have a secondary alcohol, the best choice for making a bromide is PBr3. If you have a secondary alcohol and you want to make a secondary chloride out of that, then you're going to want to use SOCl2 with a little bit of pyridine. And it's not shown here, but remember that these are SN2 reactions, so they will reverse the stereochemistry. If this starts out as a dash, then you're going to end up with wedges at the end of this reaction. You get an inversion of configuration. If you have a primary alcohol instead of a secondary one, you actually have a couple choices for the reagent you use to make a bromide. You could use HBr, which we learned in a much earlier chapter, or you could again use PBr3. Both of these are SN2 reactions, but when it's a primary alcohol, it's not a chirality center, so the wedges and dashes don't matter. Same thing down here, I can go from an alcohol to a chloride if I use acidic conditions, HCl, or now I have a new reagent that also works, SOCl2 with a little bit of pyridine. The other reactions that are on the board are redox reactions. So I'm either adding extra bonds to oxygen or I'm removing bonds from oxygen. So I'm going to draw all my oxidation steps in red. If I want to go from a single bond to oxygen to 2 bonds to oxygen, that's an oxidation reaction. But here I just want to go from the alcohol to the aldehyde. I'm not going all the way up to the carboxylic acid. So I would choose a mild oxidizing agent in this step. So we have a couple choices. We could use PCC, which is one of those chromium-containing compounds. It's kind of toxic, but it works really well. Or if you want to be environmentally friendly and use something a little greener, you could do the Swarin oxidation, or you could do the Des-Martin oxidation. So you've got a couple choices there. If I want to oxidize this alcohol all the way up to the carboxylic acid, then I need a strong oxidizing agent. So my choices here, again, there are a bunch of them, but sodium dichromate with sulfuric acid works really well. Again, that has that toxic chromium. So your greener alternative to that is to use NaOCl, which is just bleach or pool chlorine. And we're actually going to use that in our last lab this semester. If I want to reduce these carbonyl compounds back down to the alcohol, and removing these double bonds to oxygen and adding in bonds to hydrogens, then I need a reducing agent. Oh, hello. Did you come to help? You want to say hi to the camera? What's your name?
Lalo.
That's not your name. Your name is Layla. Okay, you're going to sit down and be my assistant? Will you hand me the green marker? Thank you very much. Okay, we're filling in reducing agents. So if I want to take a carboxylic acid and reduce it down to an alcohol, actually let's start with the aldehyde. The aldehyde down to the alcohol, I just need a mild reducing agent because aldehydes are very reactive. And so in this case, I'm going to use sodium borohydride with methanol. That's not a word. If I want to reduce... Oh, you're going to write something? Go ahead. What do you think the answer is? Draw it in. Almost. You're so close. I'm going to show you the answer. If I want to reduce a carboxylic acid down to an alcohol, I need a strong reducing agent because carboxylic acids are less reactive than aldehydes. So here the best choice would be, well, I only have one choice, lithium aluminum hydride. And then I'm going to add water to protonate at the end. It's so reactive that I can't add the water in the same step. Oh, don't write in there. Okay, so one thing I want to note is that our example here was with an aldehyde, but remember that this works with aldehydes and ketones.
Oh, okay.
Whoops, you got to move over here. Excuse me. Right there.
I don't know how to go.
Works with ketones also. What happened? And down here, lithium aluminum hydride, we showed it working with a carboxylic acid, but it works with esters also.
No, no.
Okay, hopefully you can see all those answers behind all the artwork. Say bye-bye.
Bye-bye. Bye-bye.